Dear students, let us discuss about how to draw the circuit diagram of BH using anchor ring and ballistic galvanometer. Let us start. So here in the circuit diagram, what we shall make the concentration, there are the main two parts. One is the battery part, another is the galvanometer part. And here is the two sections. One is the solenoid and another is the anchor ring. So here is the solenoid. In the solenoid there are the several turns and here is the anchor ring. In solenoid we will see several turns are wound on the primary, and here are the two ends of the primary. It is a solenoid, and there is a one section known as the secondary. The number of turns are there. The choice can be different by putting the contact knobs, and here are the two ends of the secondary. Similarly, in the anchor ring there are the several turns wound over it. It is the primary of the anchor ring, and there is another section, and here are the two ends of the primary. It is our anchor. And there is another section called the secondary of the anchor ring, and the several turns are there, and here are the two ends of the secondary of the anchor ring. Now the secondary of the solenoid will be connected to the ballistic galvanometer, which is moving coil type, and the ballistic galvanometer will be connected to the resistance box. The value of the resistance will be greater than the critical damping resistance of the galvanometer. It is marked as R1 here. To protect the galvanometer, we should connect one key, say K1. Whenever we will see the deflection, we will attach K1, otherwise it will be open because it is very sensitive. And the another end of K1 will be attached to the secondary of the anchor ring. Now the two ends, that is the secondary of the solenoid and the secondary of the anchor, will be connected to each other. Now there are the two main portions is that the current will flow either through the solenoid or through the anchor, and solenoid primary and anchor primary will be commonly connected to the battery. We have to remember this. So for that, what we will do, the primary of the solenoid, we are just attaching to the metal contacts of a two-way key. Here are the three metal contacts. One path is designated as A, another path is designated as B. When the current will flow through the path A, it will get the contacts through the solenoid. When the path is connected through the B, then the current will move through the primary of the anchor. So here we are attaching the primary of the anchor to the key, two-way key. Now another part is the rest part which is left, that is the primary of the solenoid and the primary of the anchor ring. They should be commonly connected to the battery part, and the battery part is connected to the false commutator. False commutator has 6 metal contact points, and we can name it, say the 6 out of 6, it is the middle one, the second knob, it is going to the common contact of the primary of both of the solenoid and the anchor. Here are the 1, 2, 3, 4, 5, 6 metal knobs, and the common path through which the current will flow, ultimately it will choose the two-way, either A or B. It is also connected to the point number 5, knob number 5 of the false commutator. 4 and 3 will be connected to have the option of the change in direction of the current when we will change the rocker's position. Now we will attach the battery. The battery is connected through some high ampere source, and it is our high ampere source, positive and negative. The value of the current is measured by the ampere meter, and it is our ampere meter. The polarity of the ampere meter is given here. This one is the positive and this is the negative. Now it is connected to some rheostat, variable resistance, through which we can fix what is the maximum current initially we shall start. Say it is the plus 3 ampere. Say. Now if we want to reduce the current from plus 3 ampere to plus 2 ampere, we must attach one resistance in the path. So here is the connection of another resistance box in series with this rheostat as shown in the figure, named as R2, and it is connected with the rheostat through a key. Say it is named as K. Now when R2 is connected with some key parallel with it, which is known as or named as in the circuit diagram as K2, say, which is kept in parallel with the R2, then the current will flow through R2 when only the K2 is open. When K2 is closed, then R2 will not in the path. So when there is a need to change the current from plus 3 ampere to plus 2 ampere, what we will do, we will initially close K2 to have the maximum value of plus 3. Then we will change the position, the key condition. K2 will be open, R2 will be in path, current will be reduced to plus 2 ampere. Then after seeing the value, we will again connect K2 and having the maximum value plus 3 ampere. When we have the sudden change of K, then the direction unchanged, the value will be changed. Now here is the connection of the another resistance R3, just the opposite direction of the false commutator, that is negative side change. The same replica of the R2K2, same combination, represented as R3K3 here. What we do actually, we just open the contacts in between 6 and 3 and we attach in between 1 and 6. For using one single R2, the full thing can be done. So here is the full circuit diagram of BH using the anchor, solenoid and galvanometer. And we have not mentioned the one key, it is important key, it is called the tapping key. I have forgot to mention it. So it is attached here to keep the galvanometer deflection in zero condition, that is to make the galvanometer in rest condition. So it is the full circuit diagram of the BH, and I think if we follow these steps, it will be very easy to draw the circuit diagram of the BH without seeing our book. So let us try to draw our circuit diagram in this way. So thank you, have a good day and goodbye.